Hey everyone. I had a handful of people ask me questions about Hamilton and Jefferson apportionment and having a little bit of trouble. So I wanted to create a couple videos. I'll extend the date on the lab, and that way hopefully that will help with our testing as well. So here we have an example. The state of Delaware has 3 counties, nice and simple: Kent, Newcastle, and Sussex. The state House of Representatives has 41 members, so we need to distribute those proportionally to these 3 counties. So step 1 in Jefferson and Hamilton both is to find the standard divisor. So we want to take the total population, and here it's given to us, 897,934, and divide by the 41 seats. Let's see if I can get that to cooperate. There we go. All right, so we've calculated this, and we end up with 21,900, and our decimal is 82927. I would leave that decimal place there as long as it is until the very end. Step 2 is the same for Hamilton and Jefferson as well. We want to find the standard quota for each county, so we're going to take the population of each county and divide by this standard divisor we found in step 1. So here we would take the population for Kent, which is 162,310, and divide by 21,900 with this long decimal. We end up with 7.4111. And we do the same for Newcastle, same for Sussex. We're dividing by that standard divisor, and we leave the decimal there for just a minute. That's our quota. So then we wanted to consider these quotas and look at the lower quota. So that's like imagining the decimal is not there. So we take 7 plus 24 plus 9, and we end up with 40 representatives. So we're short 1. So this is where the difference is between Hamilton's and Jefferson's. Hamilton's method says we just add that last seat, the extra one that we have, to the county with the largest decimal place. So we look at the original quota we had here, and the highest decimal place was 24.5872. So Newcastle will go up to 25, and Kent and Sussex will remain at 7 and 9. And we add those up, and our final total would be 7 plus 25 plus 9, which gives us the 41 that we were looking for.